Okay, so this video starts section 3.4. This lesson was for Monday, the 14th of February for geometry. So I'm starting with my lesson opener, which you're not going to have in your book, but you can jot these down if you want. Just a couple of things to kind of look at and get a reminder of. The first one is, first and second are working with absolute value. So for number one, we have the absolute value of 12 minus 5. When we solve that, you treat your absolute value like a grouping symbol. So you solve inside the parentheses or the grouping symbol before you interact it with anything else. So 12 minus 5 is 7. So the absolute value of 7, of course, is just 7. And then look at 5 minus 12. So again, this is the absolute value of 5 minus 12, which is negative 7. However, because you are calculating absolute value, when you get rid of that grouping symbol, it becomes a positive. Okay, so for number 13, again, we're still talking about order of operation. And in this case, you must solve inside the parentheses before you do exponents. That's why with PEMDAS, we have parentheses, then exponents, then multiplication, division, and then addition and subtraction. So this would be the square of negative 16 plus 3, which gives us a negative 13 squared. And when you do that, you find that any negative multiplied times another negative is a positive. So this gives you a positive 169. And then for number 4, it is often a mistake when you see squared numbers inside of a square root to think that the squared will cancel out the square root and that this would just become 6 plus 8. That would be the case if the 6 plus 8 were in parentheses, because then you would be able to combine those two into 14 and then you square that. If that's the case, the square root and the square do cancel each other out. But in this case, you actually do have to do the exponents first before you find the square root, because you don't have parentheses around the 6 plus 8. So the square root of 6 plus 8, 6 squared is 36, 8 squared is 64. And so you combine these, and 36 plus 64 is 100. So it does give you the value of 10. So it is at least a perfect square, but it is not 14, which you would have gotten if you had incorrectly added 6 plus 8 and squared it and canceled out that square root. Okay, so the first paragraph of section 3.4 on page 129, it has a lot of really important information. Let me go ahead and open a PowerPoint. Maybe. Are you gonna open? No. Well, let's see here. 3.4. Okay, so a point's location in a plane is described using an ordered pair of coordinates, which we represent in parentheses divided by a comma as the X and Y coordinates. We measure this from the reference point of the origin, which you can see on the graph there to the right. That is the point where the X-axis and Y-axis meet, and its coordinates are 0, 0. And that separates the plane into 4 quadrants. So quadrant 1, Q1 here, is a positive Y, positive X. And then it goes counterclockwise. So quadrant 2 is a negative X, positive Y. Quadrant 3 is a negative X and a negative Y. And then quadrant 4 has a positive X, but negative Y. So it's in that bottom southeast corner. Okay, you gonna move? Maybe. Okay, so let's talk about some formulas. The first formula that you come across is the distance formula. So the distance D between any 2 points is given by the formula. D equals the square root of the second X minus the first squared, and the second Y minus the first squared. Now we have example 1. I'm going to actually just go ahead and work on that through the worksheet. When and I also want to review when we're looking at a number line. In this case, I'm just looking at something that may be along the x-axis. But if this was 0, -1, -2, -3, if we had a point at -2, point A, this is the point. The point is the letter that represents the coordinate. The coordinate is the value at that point on the plane. Coordinate. I forgot how to spell. That's your coordinate. And then your ordered pair, of course, is represented with X and Y. The Cartesian plane is the plane of coordinates that measure the x-axis and the y-axis. So that's what you're seeing when you, it looks like graph paper in your book. And then here we have our distance formula. So the distance formula is the square root of the difference between the x coordinates squared plus the distance or the difference between the y coordinates squared. So in this case, they've given us an example 1. They've given us a coordinate at -2, 5 and a coordinate at 4 and 1. So without having to graph and measure, you can go ahead and use this formula to calculate the distance. So I always like to label these. This is x1 and y1. This is x2 and y2. And if you even need more visual aid, you can go ahead and just label x1 equals -2, y1 equals 5, x2 equals 4, and y2 equals 1. But then you can plug those into your distance formula and come up with x2, which is 4, minus x1, which is -2, squared, plus y2, which is 1, minus y1, which is 5, squared. This explains our lesson opener because we have some negatives going on here. Okay, so our first one, let's simplify. 4 minus a -2 is 4 plus 2, so that's 6 squared. And 1 minus 5 is -4, but -4 times -4 is a positive 16. Well, I'll get to that in a second, but it's still -4 squared. And so this becomes the square root of 6 squared, which is 36 plus 16. And simplifies down to the square root of 52. Now, you can simplify this. You want to pull out of your square root whatever you can. So you're going to need to do your prime factorization for the number inside the square root to figure that out. So 2, we know it's even. So 2 goes into 5 2 times with 1 left over, and 2 goes into 12 6 times. And then 26 is 2 times 3. So we have 2 times 2 times 3 is our prime factorization. And when you put that inside your square root, then you get the square root of 2 squared plus, sorry, that's 13. I did that yesterday too. Plus, sorry, times 13. Okay, so because this is multiplication, the square on the 2 cancels out the square root. So that actually does become a 2, but the 13 stays there. So this is 2 square root 13 is our distance. Okay, so moving on to the midpoint formula. This is the midpoint of the line segment where the endpoints are given as coordinates on a Cartesian plane. So the measurement, or excuse me, the midpoint of the x coordinate is the average of the x coordinates, and then the midpoint of the y is the average of the y coordinates. So that is your midpoint formula, which I already have written on there for you. Just put a box around it. Okay, let's go ahead and look at it as an example. So for example 2, the midpoint of xy is what we need to calculate, given that x, the endpoint at point x is -2, 3, and the endpoint at y is 1 and 5. So again, label these x1, y1, x2, and y2. so that you can plug it into your midpoint formula. So I'm actually going to do the x at the midpoint is equal to x1 plus x2, so -2 plus 1 divided by 2. And the y coordinate at the midpoint is equal to 3 plus 5 divided by 2. So the x of the midpoint is -2 plus 1 is negative. So this is -1/2. And the y is 3 plus 5, which is 8. 8 divided by 2 is 4. So the coordinate, the midpoint coordinate is -1/2, comma 4. And that's a walkthrough of example 2. Let me go ahead and do example 3, because I think I forgot to start recording today when I did that. We did have the homework assignment Monday night to do numbers 1, 4, 7, and 10. And then the answers are here if you want to pause that. The homework for Tuesday is 10, 13, 16, 19, 22, 25, and 28. So it covers more slope practice, as well as making sure that you make note cards for your formulas, the definition of slope, which you're going to want, and the 2 postulates that are on page 132. All right, so let's look at the work through of example 3. So in this case, let me just take this away for a second. We are using the midpoint formula, but in this instance, we already know our midpoint and one of our endpoints, but we're having to use that information to calculate the second endpoint. Maybe, I think I missed it. I didn't have to erase all that. So your midpoint formula, you can put an equal sign there. So midpoint equals the average of the endpoint coordinates. And so they've given you the midpoint is -1 and 1/2, and they've given you one endpoint A. So you need to find endpoint B. So you make B your x2, y2, and those become your unknowns. So in order to make those work, you have the x at the midpoint equals x1 plus x2 divided by 2. And the y at the midpoint is equal to y1 plus y2. And we can just do that. This is up here, this is xm, and this is ym divided by 2. Okay, so we know the x coordinate at the midpoint is -1. That is equal to x1, which is point A, so -3 plus x over 2. And the y coordinate at the midpoint is 1/2 equals y1, which is 4, plus y divided by 2. So you just finish these 2 equations to solve your x and y coordinates for endpoint B. All right, so first off, fraction bars are considered grouping symbols. So let's go ahead and simplify that first. And we don't do anything with it as our first step. Okay, so 2, those cancel out. 2 times -1 is -2 equals -3 plus x. And then you add 3 to both sides to isolate your variable. And you find that x equals 1. So our coordinates, that was weird. At the midpoint, we know our x is going to be a +1. Y, when we multiply both sides by 2, we actually cancel out both fractions. And so 1 equals 4 plus y, and then we subtract 4 from both sides. And this becomes a -3. So your x coordinate is -3. And you do have that at the bottom of page 130, but I feel like the way that they do it does not always, looking at it already done doesn't always make as much sense as actually seeing it being done. All right, and then the rest of this unit you should see in the video that I've already posted. So this should cover what we talked about on Monday, and then a little bit from Tuesday as well. Also, just as a reminder, you can pause it and check that homework as well. All right, thank you.